In this video, we will learn how to calculate the frequency of a tuning fork using sonometer. So these are the experimental observations. So from this we need to find out what is the root T by L. Look at the first set of reading. The mass here is M. Next we need to find out what is the tension. Tension T is given by M times G. So M is 1 kilogram. G is 9.8, so it is 1 into 9.8 is 9.8. Then we need to take root T. When you take root of 9.8, we get 3.13. Then we have the length of the vibrating segment L, which is 11.5. To get root T by L, we divide 3.13 divided by 11.5 into 10 power minus 2 meters. The answer we get is 0.2721 into 10 power 2 Newton per meter. The 10 power minus 2 in the length, when it goes to the numerator, it becomes 10 power 2 Newton per meter. In the same way, we will calculate root T by L for 1.5, 2, 2.5 and 3. We will get 5 readings for root T by L. So when you look at the 5 readings of root T by L, you could see all the 5 readings are around 0.27, 0.27, 0.28, 0.27, which means that the experiment we have done or the readings we have readings we have taken is seems to be correct, or the root T by L seems to be a constant one. So then we find what is the mean root T by L. So adding 5 root T by L and dividing it by 5, we get 0.27616 into 10 power minus 2. Next we need to find out what is the radius of the wire using the screw gauge. We know the least count is 0.01 into 10 power minus 3 meters, and the zero error is plus 3 division and zero correction is minus 3 divisions. And we know how to calculate the readings using screw gauge. In many videos I have already said. So the total reading comes out to be 0.518 into 10 power minus 3. This is the diameter. To get the radius, we divide it by 2. We get 0.259 into 10 power minus 3 meters. Next we need to find out the linear density of the wire. The linear density is given by pi r square d, and pi we know it is 3.14. R is the radius of the wire, 0.259 into 10 power minus 3 meters, and the density, that is the density of the steel wire, which is a constant, 7800 kilogram per meter cube. So substituting in the formula, we get 3.14 into 0.259 into 10 power minus 3 the whole square into 7800. So squaring this r, we get 0.062708. 10 power minus 3 the whole square is 10 power minus 6. So multiplying everything, we get ms 1642.95 into 10 power minus 6 kilogram per meter. For this we have to take a square root to get to root m. So root m is 40.53 into the square root of 10 power minus 6 is 10 power minus 3 kilogram per meter. So we got our root m now. Then we will find out the frequency, and the formula to find the frequency n is equal to 1 divided by 2 root m into root T by L. From the first table we got the value for root T by L, and root m also we got. Substituting it, we get 1 divided by 2 into 10.53 into 10 power minus 3 into 0.27616 into 10 power 2. So multiplying the denominator, we get 0.27616 into 10 power 2 divided by 81.06 into 10 power minus 3. We get, when you divide the numerator and the denominator, we get 0.003468 into 10 power 2, and the 10 power minus 3 in the denominator goes to the numerator, then it becomes 10 power 3. So you totally got 10 power 5. So when you bring the powers inside, what we get is, or when you can write 0.003468 as 340 into 0.68 into 10 power minus 5. Another 10 power 5 will come. This 10 power minus 5 and 10 power plus 5 will get cancelled, so we will get the frequency n to be 340.68 Hertz. And the frequency which we have used for this experiment is 341.3 Hertz. That is the tuning fork we have used, and we got the result as 340.68 Hertz.